Hello again. This is the professor. This is again lesson 3, and we'll be talking about right triangle trigonometry. And today, this evening, we're going to be talking about deriving a few fundamental identities. Now, let's look at the right triangle. Okay? As we see the opposite side, the adjacent side, and the hypotenuse, which is, we can go and talk about the Pythagorean Theorem, which is applied to this. A squared plus b squared is equal to c squared. Since addition is commutative, I decided to write it this way. B squared plus a squared is still equal to c squared. Now, if we divide each side by c squared, we get b squared divided by c squared plus a squared divided by c squared equals c squared divided by c squared, which will in terms give you this expression here as well. This gives you an idea of your trigonometric identities here. As you see, b over c squared, a over c squared, c over c squared, well, equal to 1. This in terms will give you sine theta squared plus cosine theta squared is equal to 1. But hold up, it's always more appropriate to write it this way than this way, here being sine squared theta plus cosine squared theta is equal to 1. This is one of your Pythagorean Theorem identities, which is stated right here. Now, let's look at a few other things here. If we want to divide equation 1, and we can say that sine squared theta plus cosine squared theta is equal to 1, we can say that that is equation 1. If we take that equation 1, let's write this equation 1 up here first. And what we want to do is we want to divide each side by cosine theta. So let's divide each side by cosine theta. I'm going to take a different color here, if we will. Divided by cosine squared theta, that is. Right? We actually come out with what? Simplifying this, what do we do? This is the relationship. How about if this cancels out here, and this is what we come up with. I love the Mondo board. The Mondo pad is awesome. It's like playing Etch-a-Sketch, remember? Whoops, there we go. There. So, what do you think this relationship is? It almost introduces you to a what? Another what? Trigonometric identity, which is one of the what? One of the Pythagorean Theorem identities. Now, sine theta, or sine squared theta, divided by cosine squared theta is equal to tan squared theta. You see this? So let's use another color here. Back to our red. So let me see. Tan squared theta plus 1. What will be the identity for 1 over cosine? 1 over cosine squared theta. What would that be? That should be secant squared theta, right? So there we go. And I'll tell you why, because the original identity, well, you know, if you got sine squared theta divided by cosine squared theta, that is going to give you tan squared theta, which is one of the quotient rule identities here. And if you look here, it comes from the original quotient identity, which is tan theta equals to just sine theta over cosine theta. And of course, with secant theta, of course, if you got secant squared theta, that is equal to 1 over cosine squared theta. That comes from one of the original reciprocal identities, which is just plain secant theta is equal to 1 over cosine theta. So we see that. So we have just derived one of the other Pythagorean Theorem identities. Let's do another one, though. Let's do another problem. Or let's derive another Pythagorean Theorem identity. And if we still take this, and does everybody have this? Of course. If you want to copy this down, rewind the tape and take some time and copy it and study it and let it sink in. If I'm going too fast, you can always stop and rewind and copy it and take as long as you need to let this material soak in. Your instructor will expect you to probably memorize this material, some of this material, and memorize some of these identities. Also, they expect you to have really neat handwriting in mathematics. Now, let's go to another one. I want to use my brush. I have my little brush and my Mondo pad here. All kinds of nice toys on here, right? So let's write that first one down again. The first Pythagorean theorem. Oops. Let's see. Oops. Okay. Let's write down that first Pythagorean theorem identity. Remember that? And now this time what we want to do is this is actually equation 1, we said. And we want to divide by cosine, or sine, excuse me. We want to divide by sine squared theta. So we want to divide each side by sine squared theta. So when doing that, let's write this over again. Oops, I forgot my sign there. We'll make sure we get the sign. And one over. Does everybody see that? So when we actually simplify this, what do we come up with? What do we come up with? We will come up with this being, let's use a different color. 1 plus, what do you think? Can anybody out there in Math Magic Land tell me what this is? Ah, I think I hear somebody. Somebody said, huh? Oh, cotangent squared theta? Is that right? I think so. Let's see, cotangent squared theta. Very good. What about 1 over sine squared theta? Okay, what? I hear? Okay, I think cosecant theta. Cosecant squared theta. Okay, let's write that down. Very good. Very good. So if you understand, and actually we could actually rewrite this as cotangent cotangent square theta plus 1 is equal to cosecant square theta, which is also another one of the what? Another one of the Pythagorean Theorem Identities. Now, this also comes from the original reciprocal identities, which is, well, of course, here 1 over sine squared theta is cosecant squared theta, and you have cosine squared theta divided by sine squared theta, which is one of the quotient identities. Well, I hope you learned something from these this little block of instruction. Again, we will continue on to make more videos and more film for you to enjoy and also be successful in. Thank you.